Hello everyone. We started new series of tutorials. Laptop accessories. And the stating video as adapters. As you know, laptops have different accessories. Battery, adapter, panel, DVD-ROM. I want to start with adapter. You see some brands of adapters in here. All of them have a similar mechanism. They have power inputs and DC output. And there is a circuit inside adapter box, which is called power supply circuit, which I'm going to talk about in the following. Adapter has two important properties. DC volt output. As you see, output is 19.5 volt in this Dell adapter, with 4.62 amperage, which means amperage and voltage are important. You should be careful about the amperage and voltage if you want to use another adapter. In fact, the adapters can be converted to each other if their output cables match. If I want to talk about adapters, I want to talk about them in several sections. First, I should say that it has a firm cover. There are different ways to open the cover. Some repairmen use hard methods for that. Some repairmen apply adhesive remover around it, and they wait until adhesive gets removed. As you may know, these two parts are connected with adhesive, and they are pressed firmly, and they're not connected with screw. The best way is the adhesive remover. There are different types of adhesive removers. Adhesive remover should be applied on the gap all around the adapter, and wait until the remover melts. Then you can remove the cover by giving a little pressure. I should say that you can do it with gasoline or paint thinner as well, because our colleague Mr. Safari has done it before. Now I want to show you the internal circuits of some adapters. I opened some of them before, but I should say that they are damaged adapters, which I'll talk about their troubleshooting in another video. This is one opened adapter. I removed the cover. I'll remove these adhesives later, if needed. There is another one, and the adhesive is removed, and you can see its different blocks clearly. Adapters are divided into different blocks, and there are a lot of information about them. And as I consider the repairing aspect, I would like to divide it into three blocks. AC input block. This block is from 220 volt AC to diode bridge. This block includes power input, fuse, filters to the diode bridge input. And this is AC block. And if you want to test this block, make sure to set multimeter on AC mode. I did the division base according to checking and testing. I divide primary power section from diode bridge to secondary coil of transformer, and also explain it, and secondary power. So there are three main divisions: AC section, primary and secondary power. And the most important block of the adapter is the primary power, which is divided to two main blocks: rectification, which is until this big capacitor, 220 volt, is converted to DC by diode bridge, and is filtered by this capacitor, and will be ready to be applied to primary power, and will be converted to AC again, and the required voltages will be received from this secondary coil of transformer, which is 19.5 volt in this adapter, and will be converted to DC again. I want to analyze the first block of adapter in this video. Some equipment are required and needed for adapter repairing and testing AC block of adapters, which you need to buy. Let me show you the equipment now. They are very important and necessary, because as you know, 220 volt is present in power input jack. It is present in this fuse. And also on the circuit's bellow. AC power is 220 volt in some countries, and in other countries it is 110 volt. It's a very dangerous voltage. It's life-threatening. So be careful when you open and repair adapters. Make sure to disconnect the adapter from power. In the next steps of testing adapters, I'll show you the required accessories for testing. The most important thing is that, when you hold the adapter, I should say that more than 300 volt is present in this high voltage capacitor. Present voltage in this capacitor remains in it even for hours after disconnecting from power. I witnessed that it applies an intense shock to human body even the next day. So electrocution can happen even when adapter is disconnected from power. Yes, that's right, and it's an intense one. So be careful about that. It burns the skin where it touches. So first thing you need to do when you open the adapter is to discharge this capacitor. Some repairmen hold wire cutter tip or metallic tool like this. Then there happens an intense spark or shock. I do not at all recommend doing that. That damages capacitor. For example, 200 volt is present in capacitor, and when you connect it like this, there will be overcurrent in the capacitor and will discharge it. It might damage the capacitor, and it would lower its usage time, or the short circuit might produce soot, and it might go between these small SMD components, and that might make problems later such as short circuit. Best thing to do is that take a look at this resistor. It's 5.6 ohm with high wattage. Hold it like this. There is no electrocution risk. That's an insulator, right? Yeah, the cover is insulator. Make sure if it is insulator or not. Meaning, if its color is removed, tape the part that doesn't have color. Adjust the pins like this and place it on the capacitor pins carefully and hold it a while. You would feel some heat on your fingers. If the voltage of capacitor is more than 200 volts, and that indicates discharging. After that, set multimeter on volt mode and place probes on two capacitor pins like this. Capacitor is discharged now. If voltage was present, you can make a short circuit by placing both probes on capacitor pins and discharge the capacitor completely, so that your ohm meter wouldn't get damaged when you wanted to check ohm amount. This is the primary carefulness. Make sure to do it, because it happened to me a lot of times when I didn't discharge the capacitor, and when I hold it this way, it gave an intense shock to my hand. But I should say that I had to throw the adapter, and when adapter falls to the ground intensely, it might damage this transformer's core, which is made of ferrite and extremely fragile, and gets damaged. So primary caution after opening adapters is to be careful about short circuit of 220 volt, and then discharge the capacitor. And on the next step, when you repair the adapter, make sure not to plug it into power immediately. That requires another equipment as well, which I brought it in here. This is a 200 watt lamp, light bulb wire lamp. This lamp is installed as series. Which means if I want to draw it for you, it would be something like this. For example, this is 220 volt AC input. We will place the lamp as series with one wire string. For example, this is light bulb. The plug is in this part that I'm going to draw. And this is the power socket. Why is this placed like this? Let's assume short circuit isn't solved after repairing. We connect adapter to this circuit. Let me show it practically. Let's assume one of these adapters is repaired. Or let me show it with the opened adapter. We assume AC block has a problem, and it is repaired, and we want to test it. You should not plug adapter cable into power directly, because if short circuit is not solved, power cables, power counter might burn, and there would even be life-threatening issues. So I plug it like this, and plug this part into the AC power. I switch it on, lamp is turned off. If there is short circuit in here, we can understand the intensity of short circuit by seeing light intensity. Lamp light indicates the intensity amount of short circuit. Let me show you the short circuit now. Be careful about these and make sure they are unplugged. This is the maximum of short circuits. It's completely short circuit. So now if I plug it, lamp will turn on intensely. So this is a complete short circuit, 100%. Let me show you the normal way as well. Adapter is okay. Lamp doesn't turn on and there is no light. Let me show you the adapter as well. It doesn't have any effect on adapter's performance. This is the adapter, 19 volt is present. This lamp is for carefulness. Make sure to make a circuit like this, which has a bulb holder, 200-watt light bulb. Some repairmen don't make this circuit appropriately or make it with wire. Let me show you an example. Don't make something like this. Try to make a fixed circuit. I'm using this circuit for decades. I use it all the times and it's very useful. It can be used in different circuits, even television, radio. It can be useful for all the electric devices with 220 volt input. Let me draw this on a paper. Let's assume it's a long cable from the plug. And I don't want to use too much wire. A 200-watt light bulb is connected to the last bulb holder. This is the light bulb. I cut it from this part into 2 wire strings and connect it to socket. This is the socket. And this is connected to plug. This is the simple circuit, which is placed as series. No matter what kind of device is plugged into this socket, it would be series with light bulb. And if the device has short circuit, light bulb turns on. And if the device works normally, depending on device's wattage. For example, if it has high wattage like a 29-inch TV, light bulb turns on for a second and then turns off. If there is no short circuit, light bulb doesn't turn on for low wattage devices. Completely turned off. Make sure if AC and DC of primary blocks are okay. Then carefully connect your device to 220 volt power directly. Set 0. And hold the cable like this. And place one probe on one of the plug's pin. And test it. Ohm meter trigger isn't moving. I try the next one, 0 appears on ohm meter. This string is connected to this string. And doesn't have short circuit to the other string. So we tested the short circuit and string disconnection all together. Let's test the other one. It doesn't matter if you touch the probe. It doesn't even matter if you place either of the probes. and test the other cable like this. This one is connected and the other one should be disconnected. As you know, the third one is connected to GND and it's not important. Phase and neutral pass through these two pins. This cable is okay. You can make sure of the cable very easily. And before opening the adapter's cover, make sure if the cable is okay or not. Sometimes you open the adapter's cover. Then you realize that the cable is damaged. A situation like this happens so many times. So make sure to make this circuit for repairing adapter. And diagnosing short circuit of 220 volt input. You need a resistor like this as well. Ohm amount of the resistor doesn't matter. It should be near 3 to 10 ohm. And choose a higher wattage so that resistor wouldn't burn. It needs to be a little big so that you can hold it with your hand. And there wouldn't be electrocution danger. So make sure to buy it. And also have analog and digital multimeters for next video's tests. So this resistor is for discharging capacitor. Big capacitor on the adapter circuit. And this is for detecting short circuit of the circuit input. Let's analyze a switching adapter. Let's analyze adapter. Switching adapters of all devices like laptop, mobile charger. Even the internal power supplies of all electrical devices, such as TV, CRT TVs, LEDs, LCDs, all monitors. More than 90% of devices which work with AC voltage use switching circuit inside them. And their work mechanism is the same. They have an AC input, which is converted to filtered DC by a rectifier circuit, diode bridge and capacitor, and by a switching circuit which includes a power switching, and the small components which are around it, and a transformer. It will be converted to a higher frequency AC, which is usually more than 50 kHz. And the provided DC will be converted to AC again. And needed voltage or voltages. Sometimes even 7 to 8 different types of voltages on some circuits can be gotten from a secondary coil of transformer in a second. There is a rectifier circuit with its filter capacitors in here. All switching adapters have this mechanism. In this video, I want to explain AC input block. As AC power is 220 volt in some countries. And it is 110 volt as some others, which is life-threatening. Do not test it with power. Disconnect the device from power. Discharge the capacitor with a resistor. And by doing 2 or 3 tests with analog ohm meter, you can easily diagnose if AC block is okay or not. I'll show it to you. Take a look. AC block includes power input jack. I should say that plug is installed in the new adapters. It might be a little difficult to work with these adapters when you open them. So try to use a connector between the plug and the power socket. In this way it would be easier to work with them. As I said, this is power input jack. And phase and neutral enter circuit. There is fuse in the way of one of these strings. This is the power fuse. 220 volt AC passes through filter capacitors. 220 volt AC passes through filter capacitors and enters diode bridge. It's a very simple circuit. Its components might be less than 10. Let me draw this adapter circuit in here. This is power input jack. 220 volt AC enters it with 2 wire strings. One of the strings passes through a fuse, which is in here, and enters a choke filter which is in here, which has 2 coils. There is a surge capacitor before choke filter. It is a filter and surge capacitor. Please show the capacitor on the circuit. This white capacitor. And this one directly goes to the other string. Phase and neutral. It doesn't matter if you connect it inversely. And these 2 power strings enter. Diode bridge, which has 2 AC inputs, and 1 positive and 1 negative. This is the diode bridge. And there are 4 diodes inside it, which I'll show you its performance in the video about rectifier. This is a total simple circuit. It has a jack, a fuse, a capacitor and a choke filter. Testing this circuit is so simple. You don't need to connect the circuit to 220 volt and face the consequences. R*1, range 1. Set 0. Let me repeat again that adapter is not connected to power. Fuse is tested like this. It should be completely 0. Fuse is okay now. We can make sure if this block is okay or not with a simple ohm test. We can even test the jack and the circuits in its direction as well. Place one probe on one of jack pins, and another probe on one pin of diode bridge. As you see, it's connected. AC is written on the diode bridge and that's the input. Now I place the probe on the other pin of diode bridge. Why? To see if there is short circuit or not. No, there is no short circuit. Now I place a probe on the other jack's pin. It is connected to this pin of diode bridge, and it should be disconnected from this pin. With this simple ohm test, we realize that the circuit is completely okay. This is another newer adapter. It's like the other one but it has more components. Power input jack, 2 filter capacitors, and 3 choke filter. And the component at the bottom is its fuse. Let me zoom in a little. And T3.15 is written on it, meaning 3.15 ampere is this fuse's tolerance, and it will burn if more current is used. This is diode bridge, which is connected to GND, so that it gives its heat to heat sink. As you see, there are some adhesives around the components, which you can see under the circuit as well. You should remove these adhesives carefully by the time of testing. Be careful not to remove the SMD components from the circuit while removing the adhesive. Testing this adapter is like the other one as well. After removing and cleaning adhesive, you can test the ohm of jack to AC pin. It's okay if ohm appears. But if ohm doesn't appear, you can check short circuit direction, which includes fuse and PCB circuit, and solve the problem. The component which usually fails in AC input block is fuse. Changing fuse is easy in this kind of adapter. You need to take out the fuse. For example, if fuse is burned, ohm meter shows the disconnection. Fuse amperage amount is either written on the fuse itself or on the PCB. F4A, 4 ampere with 250 volt. You need to get a 4 amperage fuse and place it in its block, and the problem will be solved. Other components don't fail in here, unless the jack is damaged by contacting. Then you can change the jack. A question may arise in here. The fuse on this adapter is like an IC. What should we do if we couldn't find the same fuse? Let me show you what some repairmen do with burned fuses. These are 2 pins of fuse. Let me show it with ohm meter. I set it on R*1 and place probes on 2 pins of fuse. As you see, this fuse is burned. What should we do? Some repairmen solder wire in here and solve the problem in this way, which I do not recommend. Because if the fuse burns again, it would make an intense contact and destroy the PCB. And this block gets black. You need to remove tin with desoldering pump and take it. Cover of some of these will be opened, and you can pass a wire through it. Fuse is like this. It looks like a capacitor, which has 2 pins. Top of some fuses can be opened, and you can see the inside. And 2 pins can be seen from the inside like this. You can connect wire delicately like this if you want to. I'll tell you what kind of wire you need to choose for this. If this fuse is tightly closed and unopenable, tighten the wire from under this pin and pass a thin wire to this pin, so it is placed under it. I show you a piece of wire. This is the adapter's cable. Thin strings inside the cable. Each one of these wire strings tolerates 2 ampere. Which means, for example, if this is 3.15 or the other one is 4, twist 2 of them, like this. And we assume this is the fuse's pin. We twist the wire around the pin like this and solder it. And solder wire around the other pin as well, and cut the extra wire. This stays under the fuse pins. So if you couldn't find the exact same fuse, you can pass wire under it. Each one of the wire strings is 2 ampere. The power cables which has thick wires inside them. Each one of the wire strings is 5 ampere. This is not the standard one, but on my experience the standard ones are 5 ampere. You can calculate the amperage written on fuse and make a fuse with the wire strings. The white wire strings usually have high resistance. They wouldn't get oxidized and have high durability. Some repairmen solder it. I don't recommend that, because by soldering, these 2 wires get thicker, and its amperage raises. So this is it. In the next videos, I'll analyze the rest of adapter blocks, which are all DC. Thanks for watching.